Okay, in this session, we will be discussing distance and midpoint. Alright, these two topics are basically formula based, so not a whole lot of depth as relates to concept. We'll start by discussing distance first. So give me a minute here to try to see if I can get some axes drawn for you. Well, that's not what I want. Let's see. Here we go. This is what I want. Alright, so let's find out. That's going to be, let's say, our y-axis. Alright, we have our y-axis, and then we have our x-axis. Okay. So our x and our y, and let's just pretend, I know this y-axis is a little bit off the line, but just bear with me, pretend that it's actually on the line. So let's say we have 2 points. So let's make a point here at, let's say, 2, 3. So we can make a point there at 2, 3. And we can make a second point over here at 1, 2, 3, 4, 5, 2, 3, 4, 5, 6. Let's say up here at 5, 7. Let's see, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. Okay, so we have 2 points, A and B, 2 points. Now, what we're wanting to do is find the distance between these 2 points, or let's say if these points were connected, what would be the distance or the length of this segment. Okay, so the distance between these 2 points, between A and B, would be the same as saying the length of this segment of segment AB. And the way we find distance is by using the following formula. Distance equals square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. Alright, so all of that under the radical. In this case, we're talking about points A and B. And point A, we know, is over 2 on the x to the right, so that's positive 2, up 3 on the y, so that's a positive 3 on the y. And we know point B is over 1, 2, 3, 4, 5 on the x, so positive 5 for the x, and up 1, 2, 3, 4, 5, 6, 7 on the y, so 7 on the y. So in this case, my x1 would be the 2, my y1 would be the 3, x2 would be the 5, y2 would be the 7. Now that's just personal preference. If you prefer, you could make this point be the first point, so 5 be your first x, so 5 could be x1 and y could be y sub 1, and 5 could be x1 and 7 could be y sub 1, and the 2 could be x sub 2, and the 3 could be y sub 2. So it doesn't matter whether or not you consider this point to be the first point, or if you consider this point to be the first point. The main thing is that you're consistent with your x1 and y1. Okay, so I'm going to make this point x1, y1. So I'll make this point x2 and y2. So I'll say y2, alright, or x2, excuse me, which is 5 minus x1, which is 2 squared, plus y2, which is 7, minus y1, which is 3 squared, and again that's all under the radical sign. So 5 minus 2 would be 3. 3 squared would be 9. So that would give us a 9. 7 minus 3 is 4. 4 squared would give us a 16. So now what we're looking at is 9 plus 16, which equals the square root of 25, which equals plus or minus 5. Alright, so now we know that the distance from A to B would be considered 5 units. Alright, we don't know if it's feet, meters, inches. The problem didn't specify, but it's 5 units between A and B. So if it was a segment, if there was a line connecting these two, then the segment AB would be 5 units long. Alright, now when we calculated the distance over here, we saw we got a plus or minus. But anytime we're talking about distance between 2 points, it will always be positive. We don't get a non-negative distance. Okay, so we would go with just the positive 5. We wouldn't say plus or minus 5. We would just say 5. Alright, let's try another example. Let's see. Let's go with, okay, if I just gave you, without graphing them, if I just told you you had 2 points and point X is -1 and 5 and point Y is 1, 2. Okay, and I don't want to go with the X and Y because I don't want to confuse you. So let me change those. Let me say point C and point D. Alright, so I'm not going to actually plot the points. I'm just giving you 2 points, and we want to know the distance. Find the distance between those 2 points. So again, X1, Y1, X2, Y2. So you put it in your formula. X2 minus X1. Well, notice X1 is a negative number, so minus a negative becomes a plus, squared. Then you say Y2, which is 2, minus Y1, again squared. So 1 plus 1 is 2, 2 squared, 4. 2 minus 5 is a -3. -3 squared is 9. Okay, so what we're looking at is square root of 4 plus 9, which equals square root of 13. Alright, 13 cannot be simplified any further. It is prime. 13 can only be its only factors are 1 and 13. Its only integer factors, let's say, are 1 and 13. So again, 13 is prime, and we only use the positive version. So our distance between these 2 points would be the square root of 13 units. Okay, so that's distance. Now we could take these same points. Alright, let me erase right quick. I'll leave the actual distance formula there for you. Come over here, erase this here, okay, and I'll erase this over here. Alright, so now we've determined distance for 2 different sets of points. So now what we could also discuss is now midpoint. Now with distance, when we were finding the answers, we noticed we got some final value. You know, distance was some set value from one point to another. But when we go to look for midpoint, we're not looking for a value, we're looking for a location. And we depict our locations in terms of the X and Y axis. So for midpoint, we now go to X sub 1 plus X sub 2 over 2, Y sub 1 plus Y sub 2 over 2. So if you notice, midpoint is now given in the form of a point because you're looking for a midpoint. You're not looking for a middle distance, you're looking for a midpoint. And because you're looking for a point or a coordinate or ordered pair, the answer should be in coordinate form with an x value and a y value. And notice for midpoint, it's denoted by a capital M. You have to make sure that when you're talking midpoint, you're using a capital M, because a lowercase m would no longer reflect midpoint, but it would now depict slope. So lowercase m is used for slope, capital M is for midpoint. Okay, so we can go back to the previous two examples we used. So we have our A and our B as our first example that we did for distance. So now let's say we had these two and we wanted to know, okay, what the midpoint of these two would be. Alright, so what point would lie in between these 2 points? Midway, halfway in between. So we have our x1, y1, x2, y2. So now we would plug in x1 being 2 plus 5, which is our x2, over 2, and then y1, which is 3, plus our 7, which is y2 over 2. So we end up with 7 over 2, which I would leave in fraction form. Even though it's an improper fraction, I'd leave it in fraction form. Okay, and 3 plus 7 is 10 over 2. 10 over 2, which is just 5. Alright, now for the sake of graphing, I'll turn the 7 over 2 into, what is that, 3.5? Alright, 2 goes in 7 3 times, with 1/2 left over, so 3.5 and 5. So my x value is 3.5, my y value is 5. So this point would be halfway between this A and this B. So let's look. So if this is x is 1, x is 2, x is 3, x is 4, well then x is 3.5 would be halfway between x is 3 and x is 4. So halfway between would be about right here, would be x is 3.5. So we said x is 3.5 and we're going up 1, 2, 3, 4, 5. So right there. So we're looking at a point that it will roughly be right here. So this point, and I'll make it M, alright, would be halfway between A to B. So A to M plus M to B would give you the distance of A to B. Alright, so M would be the midpoint of A to B. Alright, let's find midpoint for our second example we use with distance. So we have these two coordinates listed over here, point C, point D. Okay, and we want to find a midpoint between these two. So x1 -1 plus x2, which would be a +1 over 2, comma, and then our y1, which is a 5, plus y2, which is a 2 over 2. -1 plus 1 gives me a 0, so I have a 0 for my x. 5 plus 2 is a 7 over 2, and we just said 7 over 2 is the same as saying 3.5. So this point here would be middle distance between these 2 points. Alright, so my midpoint would be 0, 3.5 for C and D. Okay, so that's all it is to finding midpoint. Alright, so let's look at one last example of distance. Go back to distance, look at one last problem on distance. So let me get my eraser. Erase. Okay, erase that. Erase this stuff here. Just bear with me for a moment. Alright. let's say, okay, now I'll go ahead and erase these two. Okay, so again, we shifted our focus back to distance. So now what I want to do is say we have a point here, right here, and this will be point C. Alright, so we have a point there, and that'll be point C, and point A, B, and C can be connected to form a triangle. Okay, so we have a triangle formed here, and so I could ask, what is the perimeter of this triangle? Alright, we have the points. Alright, and we can go ahead and list what point C is. C would be a -1, and what's this? 1, 2, 3, 4, 5, 6, a -1 and 6. Okay, so we have 3 points, and we want to know the perimeter. Okay, the perimeter. And perimeter is nothing but the summation or total of all the sides of a figure. Alright, so if it was a rectangle or a square, it has 4 sides, so you would add up all the sides. In this case, it's a triangle, so you'd add up this side plus this side plus this side. You'd add those sides up, and that would give you the perimeter. Think of the fence around your backyard. That's perimeter. If you want to know how much fence you need for your backyard, you just add up the sides of your backyard, and that would give you fencing. Or perimeter for a room would be the walls. Okay, so in this case we want to find the perimeter of this triangle, and the way we would do that is just by finding the distance from A to B, from B to C, and from C to A. So we'll say that'll be distance 1, A to B. From B to C, we'll call that distance 2, and then from C to A, we'll consider that distance 3. So we'll find those 3 distances. So A to B, we already found that distance in our previous example, and we found that distance to be equal to 5 units. So now let's look at the distance from B to C. So B to C, we would have, if we wanted to, it doesn't matter which one is x1 and x2, so I'll make this x1 and y1 since I already have B as x2, y2. So x2, which would be 5 minus x1, which is a -1, so minus negative will make it plus. So plus 1 squared plus y2, which is a 7, minus y1, which is a 6 squared, and again we're taking the square root of that. 5 plus 1 is 6, 6 squared 36, 7 minus 6 is 1, 1 squared is 1, so you have 37, square root of 37. That's considered to be prime. Its only factors will be 37. Its only whole number factors or integer factors will be 37 and 1, so prime. So the distance from B to C, which is distance 2, would be square root of 37. Okay, and let's see if we can find C to A. So D3 now we want to find D3, and since we have C as x1, y1, we can change A to be x2 and y2 now. So our D3 is going to be square root of y2 minus y1 squared plus x2 minus a negative, so it's plus squared. That's 3 minus 6 is negative 3. Negative 3 squared is 9. 2 plus 1 is 3. That's going to give me a 9. So I'm looking at square root of 18. Okay. And that gives me, what is that, a 9 times a 2? 9 times 2. So you have square root of 9 times the square root of 2 gives you square root of 18. So you end up with 3 square root of 2. So D3 would be 3 square root of 2. So the perimeter would be D1 plus D2 plus D3, and that would yield the perimeter of triangle ABC. Perimeter of triangle ABC. There you have it. Alright, so that pretty much sums up everything you need to know about distance and midpoint. As always, if you have any questions on any of this information, please feel free to contact me. You have my email and you have my my telephone information, so I look forward to hearing from you with any questions or concerns you may have regarding this the content that we've covered today. So at this time we will end this session.